Hello students, Mr. Kaczynski with you. Got lesson 8.1, quadratic models. Although this picture and graph kind of show a real world application of quadratic models, we're going to actually concentrate on the basics today, and we'll get into more real world uses tomorrow most likely. Okay, so let's use a graph and a table to approximate solutions for each equation. This is going to be calculator heavy first part here. Grab your calculator, follow along, pause as necessary. So what I like to do on these is get 0 on one side of the equation. You don't have to do this step, but for me it makes it a little bit easier. So I'm going to rewrite the equation as x squared minus 8x minus 9 equals 0. 16 minus 25 is negative 9. So then I'm going to go to my calculator. I'm going to graph y equals x squared minus 8x minus 9. And I'm going to go to my table, and I'm going to look for where this is equal to 0. There I see a 0 at negative 1. And because parabolas are formed by quadratic models, I assumed there was going to be another one, and there's the other one, 9. So negative 1, or no, 0, yeah, negative 1 and 9. So x equals negative 1 and 9. All right, on a graph, how does that show up? Let's go to the graph. Hit the trace button, type negative 1, there's 0. Type 9, there's 0. So it's the x-intercepts of this blue equation. One more thing we can do on the main screen is we can do negative 1 squared minus 8 times negative 1 plus 16. And when I hit enter, this should be 25. It is. If I hit second enter, I can bring the equation back up. Let's delete that negative sign, put in a 9. Delete that negative sign, put in a 9, hit enter. Again, I get 25. So without a doubt, negative 1 and 9 are the solutions. All right, one more time. Let's add 2 to both sides. There are no like terms on the right, or on the left rather, with that 2. So we get 2x squared minus 9x plus 2 equals 0. We're going to solve this equation using a table. So let's go to y equals, clear that old one, 2x squared minus 9x plus 2. Go to the table, and I'm looking for 0. You know what? I don't see it. Somewhere between 0 and 1 is where this goes from positive to negative. So somewhere in there the input is 0. So I guess we could say, where's the other 0? Went past it, didn't I? There it is, somewhere between 4 and 5. So 0 point something and 4 point something. All right, that's a weakness of the table, isn't it? I knew that was going to happen, by the way. But you can do a table set. So let's go somewhere between 0 and 1, table set. And I could start at 0, and I could go by 0.1s. When I go back into the table, we might be able to get a little bit closer. Yeah, so something like 0.2 be pretty close. And I go to the table set and say I want to start at 4, and start at 4 and go by 0.1s. So this is called drilling into the table. And there I can see it's about 4.2-ish or so. So let's go back to the graph, or to the graph for the first time. So trace 0.2, really close to 0, 4.2, really close to 0. I'm going to show you another function. Let's go calculate. So if I go second trace button, I'm going to look for the 0. Option number 2. It says left bound. So what I'm going to do is I'm going to move my cursor to the left of the x-intercept. Right bound. I hit enter there. And I'm going to hit enter on the right side. And then it says guess. You just You see those two little arrows right there. So it knows that the 0 is somewhere in between there. I'll hit enter one more time, and there it is. Remember I said it's about 0.2? So here's what we're going to do. We're going to say x is about 0.23, or let's do it again. Second calc, option number 2 is the zeros. Left bound, I'm going to move close to the left of this intersection, hit enter right about there. And I'm going to go a little bit to the right of it, hit enter again, hit enter a third time, and it says 4.27. 4.27. Notice that doesn't come out 0, but that's 1 times 10 to the negative 12th, which is like 0.0000000000001. It's really close to 0, close enough. If I go back to the main screen and I do 2 times 0.23 squared minus 9 times 0.23 plus 2, this should be really close to 0. It's not 0 because remember I rounded. If I hit enter again, and I'm going to insert a 4 there, 4.27, insert a 4 here, second insert 4.27, hit enter. Whoa, what did I do wrong? Oh, there we go. All right, now it should work. There it is, about 0, pretty close. All right, so there's a limit here using the calculator. We can't get the exact answer, but that's a rounded answer. All right, now we're going to use a symbolic method, balancing, to find exact solutions. Those were, 1A was exact, 1B wasn't. Okay, so let's go through this. I'm going to actually get x by itself this time, so I'm going to add 50 to both sides. That'll give me x squared equals 49. And then I'm going to take the square root of both sides, and that'll give me my solution, actually. Square root of x squared is x, and the square root of 49 is actually positive or negative 7, because 7 squared is 49, and negative 7 squared is 49. So since I'm on my calculator's main screen, let's do negative 7 squared minus 50. That gives me negative 1. And let's do positive 7 squared. And that also gives me negative 1. If I go to the calculator and I type in, how about x squared minus 50? And I go to the table. Oh, let's go table set. Start at 0, go by 1s. Go to the table, go down to negative 7, I get negative 1. Go up to positive 7, I get negative 1. Go to the graph. Trace. Negative 7 gives me negative 1. Positive 7 gives me negative 1. All right, let's do it again. All right, so this one I'm going to subtract 7 from both sides. That gives me x plus 1 squared equals 12. And then I'm going to take the square root of both sides. That'll give me x plus 1, because the square root of x plus 1 squared is just x plus 1, equals plus or minus the square root of 12. And then I'm going to subtract 1 from both sides. And that gives me my solution. X is negative 1 plus or minus the square root of 12. That is an irrational number. We'll talk more about what irrational numbers are in just a second. That cannot be simplified. Okay, so let's do this. Let's go back to my main screen. Clear. I'm going to do negative 1 minus the square root of 12. Enter. I'm going to store that. Here's the store button right next to the 1 as x. And then I'm going to do parentheses x plus 1 squared plus 7, and this should be 19. It works. And let's do that again. Negative 1 plus the square root of 12. Store that as x. And do it again here. X plus 1 squared plus 7. 19 again. If I go to the y equals function and I type in the original equation, x plus 1 squared plus 7. Actually, let's do that. I'll take my window up to 25 so that that 19 fits. Okay, if I go trace, negative 1 minus the square root of 12. See, that gives me 19 right there. And how about negative 1 plus the square root of 12? It gives me that number right there. So if I wanted just like normal looking numbers, I could round a little bit, right? Let's go back to the graph. That's probably an easier way. Trace negative 1 minus the square root of 12 is about negative 4.46. And negative 1 plus the square root of 12 is about 2.46. So these are approximate, these are exact. That's why I got the box around that. Let's do it again. How about, let's divide this by negative 2. That means I got to divide the other side by negative 2. Gives me x plus 1 squared equals 7. Let's take the square root of both sides. That gives me x plus 1 equals plus or minus 7, positive or negative 7. It's got two square roots. Let's subtract 1 from both sides. And that's going to give me x equals, oops, that should be not plus or minus 7, but plus or minus the square root of 7. X equals negative 1 plus or minus the square root of 7. That's the exact answer. Let's figure out what the rounded answers are here. Negative 2 parentheses x plus 1 squared. I'm going to take my window down to negative 20 to fit that negative 14 in there. Hit the trace button. Type negative 1 minus the square root of 7. That is exactly negative 14. So we could say one of our approximate answers is negative 3.65. It's about negative 3.65. And the other one, negative 1 plus the square root of 7, also negative 14. It's about 1.65. So those are approximate. This is exact. I think we got one more of these. Bigger one. Let's add 9 to both sides. So what I'm doing right now is I'm trying to isolate this squared quantity of x plus 7. I'm trying to get it all by itself. Negative 4 plus 9 is 5. Let's divide both sides by 2. Ugh, this is going to be ugly. Let's take, that'll give me x plus 7 squared equals 5 halves. And then let's take the square root of both sides. That's ugly. X plus 7. Oops, I don't need those parentheses. X plus 7 equals plus or minus the square root of 5 halves. And then I'll just simply subtract 7 from both sides. And we'll get our answer. X equals negative 7 plus or minus the square root of 5 halves. Whew. Let's use the calculator again. Clear 2x plus 7 squared minus 9. I'm going to use a standard window here on Zoom 6. All right. So trace it, -7 minus the square root of 5 over 2. That is negative 8.58-ish, which does give us exactly -4. All right, so x is about negative 8.58. Let's do the other answer, which is -7 plus the square root of 5/2. Yep, that gives me -4, which is about -5.42. Those are the approximate solutions. The exact solution is right there. -7 plus or minus the square root of 5/2. Okay, lots of calculator work. We have solved equations like this kind of before. All right, let's define some number sets. Okay, the real numbers. Any number you can point to on the number line includes all rational and irrational numbers. Okay, basically everything, almost everything, okay, is a real number. There are imaginary numbers though, and we'll talk about those in coming lessons. So basically, if you can see it and point at it on a number line, it's a real number. A rational number can be written as the ratio of two integers, also known as a fraction. Okay, so it includes all fractions and terminating in repeating decimals. If I can write it as a ratio of two integers, two whole numbers, then it is rational. Okay, we saw a bunch of irrational numbers. They are any real number that is not rational. That would be like this answer right here, -7 plus or minus the square root of 5/2, which came out as these two ugly decimals that never terminate, they never stop, and they never repeat. Like pi is an irrational number, okay? Lots of square roots are irrational, not all of them. The natural numbers are also known as the counting numbers. They start at 1, and then they go up by 1 after that. So 1, 2, 3, 4, 5, 6 to infinity. Those are the natural numbers. They're also known as the counting numbers. The whole numbers are the natural numbers plus one more, 0. So the whole numbers start with a number that looks like a whole. 0. Looks like a whole, right? So 0, 1, 2, 3. So it's basically all the natural numbers and 0. And integers, I talked about reading a ratio of integers. What are integers? They are the whole numbers, 0, 1, 2, 3, 4, 5. And their opposites, -1, -2, -3, -4, -5. So these are number sets that we'll talk about and use in our definitions here throughout this lesson. But irrational and rational, we saw a few of those today. The answer to 1a, those are rational numbers. The answer to 1b, those are irrational numbers. All right, that's all I've got for you. Start on the 8.1 practice your skills exercises.